I'd like to welcome everyone who's here. We're going to hang on for a few more seconds. We always start promptly at the top of the hour. And actually, I see that it's now promptly at the top of the hour, so we're going to get started. My name's Scott Webb. I'm editor of Aqua Magazine, and I'm thrilled to have a well-known expert here today to tell us some exciting news about research that will change the way we look at water care. I was very excited when we started to talk about this webinar because it answers a lot of questions that I've had over many years, a lot of new material. So without further ado, I'm going to turn it over to Alicia Stevens. She's the Director of Training and Education for Biolab and an icon of pool care education in our industry. So take it away, Alicia.
An icon, Scott. That's a lot of pressure.
It's true. For 20 years, you have really carried pool care education.
Well, thank you. Good afternoon, everybody. Thank you, Scott, for the introduction. As he said, my name is Alicia Stevens. I am the Director of Training and Education for Biolab. I have been with Biolab for 23 years now, so made my career kind of in one spot, but came out of college, and you know how it goes. Somehow got in the pool industry and never got back out again. So along the way, I discovered a passion for training. So that brought me here today, and I have a science education and a training brain. So the two of those married very well together for a career in the pool industry. So I'm very, very happy to be here with you guys today. Although growing up, I always said I was going to be a backhoe driver. So I don't know how I ended up in pools, but I think that's my retirement plan. I'll just dig pools in the future. So, but welcome to this webinar. We're excited to be here. Biolab is excited to have an opportunity to bring some information out into the industry that we have been collecting and researching and doing some work with over the last couple of years that we want to have an opportunity to talk about and to really increase the knowledge that we have about a specific topic in the industry, and that's algae. So what we're going to do today is we're going to just jump into the science of algae in swimming pools specifically. We're going to talk about what we know and what we think we know, and then kind of the new stuff that we know now and where that's led us as far as product development and formulations and things like that. We've done some really cool things with our research over the last couple of years, and it's really served us well, and being able to serve, you know, pool professionals better as far as being able to prevent and control and get rid of algae problems. So we're going to kind of walk through the process today of where we got started and what we found along the way and what that led us to. Anybody that's familiar with Biolab knows we have a bevy of brands out in the industry. So we have, you know, we have our BioGuard brands, we have our natural chemistry brands, Pro Series, things like that for the service professional. So we have options within all of our brands that fit the niche of the things that we're going to talk about today. I'm going to hone in on some of our natural chemistry products because they are the products that everyone here can get from your local distributor. So when we talk specifics about products, we're going to talk about that. If anybody wants additional information on other brands, then please just reach out to me and let me know. But as we talk about products along the way, we're going to talk about those specifically. So what do we know about algae? Well, where does it come from is always the first thing people ask, because you can go from a crystal clear pool, right, that looks wonderful, kids are swimming in it one day, to almost overnight, sometimes it does happen overnight, you end up with this green swampy mess that you see over towards the right hand side of your screen, and you're never quite sure how it gets there. You're like, how do we get to that green pool so fast? And one thing that everyone needs to realize is that algae gets into pools from everywhere, is really the short answer. From natural water sources and plants and soil and trees, and different structures, runoff. You see in the middle pictures dogs jumping in the pool and bugs and kids getting in and storms, and that the picture in the top left is a bird. Someone did research on birds specifically, how many times you see birds around and in your pool, but a typical bird has more than 100 different kinds of algae found between its feet, its feathers, and its beak. There's like 25 different kinds found in its beak alone. So all of those things, all of these things that you see here, are constantly introducing algae spores into the pool. So it's not hard to get algae in. And the life cycle of algae is very simple. It starts as one cell or one spore. It has all of the nutrients and all the things that it needs, and it grows and it reproduces. And 10 cells become 100, become 1,000, become 1,000,000, become a green pool and a problem. So we want to catch it early. We want to prevent algae from happening, but in those times we don't. We want to be able to get rid of an algae problem if it gets started in the pool. So in the pool industry, I think that we could all agree that we classify algae into 3 categories, right? And it's really based on where is it and what color is it, right? So in the industry, we say, is it green algae? Is it mustard, or sometimes called yellow algae? Or is it black algae? And we know the characteristics of those different types of algae, right? Anybody that deals with green algae knows it turns very quickly. It colors the water and lives throughout all of the pool water. You can find it on the surfaces, but it usually brushes up pretty easily. It lives out in the main body of water also. It's very easy to get, but it's usually pretty easy to get rid of. So when the pool goes green, you can shock it, you can add an algicide, you can usually get rid of it pretty quickly. Now, mustard algae or yellow algae, those words are interchangeable. That algae is different, right? It's more of a yellow color. It settles onto mostly the bottom of the pool, a little bit on the sides, but mostly on the bottom. It looks like dirt. You can brush it up. You can watch as it fluffs up into the water, and then it will settle back down, usually in pretty much the same spot. So it's something that it's a little bit hard to get rid of simply because it's hard to vacuum because it does fluff up very easily. And there's some challenges to being able to kill it. We'll talk about that in a minute. Black algae, pretty standard. Everybody can picture black algae in a pool, right? Stuck to the surface, usually in plaster pools, usually in rough plaster pools. If you look close enough, you see that black algae grows in circles, but it grows into the surface. So it's attached to the bottom or the sides of the pool and can be very difficult to get rid of. So as professionals, this is how we classify algae, right? And for the most part, it's effective. We have a way to treat green algae. We have a plan for that. If you have mustard algae, there's usually a different procedure to do that, but you know usually what works, right? Black algae is a little bit different. You approach that differently than you would green algae, but you have a plan for that. And it does work a lot of the time. But we wanted to dig into what makes up green algae, what makes up yellow algae, what makes up black algae, and is there a better way to get rid of it, or a better way to kill it, or a better way to prevent it? So we started digging around, and this is research that was undertaken by, we have at Biolab, we have our own formulations chemists, we have our own research scientists, and we have our labs on site. So here I work out of the suburbs of Atlanta, Lawrenceville, Georgia. And here at our offices, we actually have a pool park behind our building with pools, simulated in-ground pools. We have pop-up pools, above-ground pools. We have hot tubs. And then we have a whole bay or a warehouse full of, we call them micro pools or mini pools, but they're these 4x4 wooden boxes that we work with a manufacturer to have vinyl liners made for them, and they simulate real pools. So we plumb them. I say we, I don't do this particular part myself, but we plumb them, we hook up pumps and filters, we cut skimmers into the sides of them. So we simulate a real pool environment. So we have all sorts of different ways that we undertake our research when we're looking at something. This particular research was focused on algae. So in the world, there's tens to hundreds to thousands of species of algae. We found that in the pool environment, there are 13 major groups. And these are characterized by a lot of different things. They're characterized by what color are they? Do they have chloroplasts, or what kind of chloroplasts? And those are the internal organs of the algae. What kind of reserves do they have? What kind of covering makes the cell membrane or the outside of the algae cell? Do they have flagella? Flagella are what I call little algae feet. Flagella, little flippers that can move algae around in the water. So these are the things that will characterize algae as opposed to green, yellow, or black. there's some different things that you really need to look at to truly determine what kind of algae you have. So we went in and we tried to remove our preconception of green, yellow, and black and say, okay, what's really in pool water? And we did this in a couple of different ways. We took our pools in our pool park and we let them go green. We stopped treating them. We let them go green. They turned green. We collected the algae and we started characterizing what's in there. We let mini pools go green and collected what came out of there. We collected water samples from different places around the country and we identified the types of algae that were in there. So we really did some research on getting real world data on what type of algae actually grows in a pool. And we found out some really interesting things. So let's start with the most common, right? I think we would all agree that green algae is the most common type of algae in pools, right? It's the fastest growing, it's the easiest to get in a pool, it's still the easiest to get rid of, right? In that big classification of green algae, the most common type is chlorella. Okay, this is a typical green algae. You can see in the bottom left picture that that's chlorella under a microscope. Very, very vibrant green color, which is why it turns a pool very green when it's growing. Chlorella is easy to control. Chlorine, for example, kills chlorella very easily. So chlorella, when it gets started in a pool, it's very, very easy to control. You can kill it, you can get rid of it, you can clean it up if you have a problem with it. So this pool on the bottom left, if that's chlorella in the pool, you're not going to have a real hard time getting rid of that. You're going to be able to clean it up pretty quickly and get that pool back to normal. Now, as we dug deeper, we found that while we expected to find chlorella, that's what we expect to find in pools, right? We found some other green algae in the swimming pool. And when we collected the samples and we started classifying, we found an algae called Syndesmus. You can see that here on the left with the red arrows on the picture. Syndesmus was a completely different type of algae. That's still green. And when you see a pool, I'm going to go back real quick. When you see a pool like this green swampy pool over here, just looking at that, you don't really know if you're looking at chlorella or maybe you're looking at Syndesmus, right? You don't know the difference because in a pool, it's just going to present as a green pool, right? So we found Syndesmus. It was growing, it was reproducing. You put it under the microscope and you can see that while it grows in those kind of oval or circular spores, Syndesmus sticks together in groups. It was very strange. It was always even numbers also, which was bizarre. 2, 4, 6, 8, maybe 10 of them stuck together. But you see they form these long chains of algae. Completely different behavior than what we found with our typical green algae, right? Our chlorella. So Syndesmus acts differently, it grows differently, it reproduces differently. And what we found further down the line when we were researching how to kill different types of algae is that Syndesmus actually does not respond well to copper. Now, I don't know what you guys use on a regular basis, but there are, and I know in a lot of our products, there are a lot of copper-based algicides out there because copper is very effective at killing algae and helping clean up swimming pools. And that's still true. Copper is very effective. But in this case, if this green pool, whoops, going the wrong way again, if this green pool was caused by Syndesmus and you do a copper-based algicide, do you think it's going to work very well? No, not really. So I'll ask the question, how many of you have ever gone out to a green pool? You look at it, you say, this stinks, but I know how to take care of this. And you put in your chalk and you put in your copper algicide and you expect to go back the next day and see maybe a cloudy pool, but not green anymore. And you go back, you've done all the right things and you go back to the pool and it doesn't look that different. And you say, well, I did everything that I always do and it works, 95% of the time. Why didn't it work today? And your gut instinct, my gut instinct was always, well, let me do it again and try the same thing over to see if it works. In reality, what could be happening is that green pool is being caused by something like Syndesmus and you're doing a copper-based algicide. So it's like, it's not responding. It's like, okay, put the copper in. I don't really respond that great to it. So you're not effectively killing that algae, and it can create problems with trying to clean up an algae bloom. Now, again, along the same lines, we're classifying, remember, as green algae. You can see to the right of my screen a different kind of green algae called Hematococcus. And this looks very much, let me go back one just real quick, very much like chlorella. It's round, it's a very vibrant green color. But you can see in the middle that this has chloroplast. It's different on the inside of the algae cell. Now, our scientists, they dug into what that meant and what processes that feeds and all that stuff. We, as pool professionals, we don't need to know that. I'm a nerd, but I'm not that big of a nerd, right? What I do want to know is how this algae responds to algicides, etc. So Hematococcus was a little bit different. You look at this, you think, oh, it's another kind of green algae. I know how to deal with that. But then as Hematococcus started to mature before we killed it in the pool, it started to do something we did not expect. How many of you have ever heard of blood algae? Now, we've always said there's no such thing as red algae. If you have red algae, it's something else. You know, true red algae is found in the ocean, is toxic, etc. We don't get red algae in swimming pools. And technically that's true. This is a variation of a green algae, but as it matures, Hematococcus turns this kind of rusty red color, and it grows on the surfaces, it sticks in the cracks and crevices, and you actually get a red color of algae growing in the pool. And it's still green algae. It's going to react a little bit differently to treatments because it's not the same, it's not chlorella, right? It's not what you expected it to be, but you actually can have red algae or blood algae in swimming pools. We didn't realize this. Usually when we saw red algae, we blamed it, you know, we've got algae and it's got iron in it or something along those lines. But in reality, it's this particular type of algae that grows and reproduces. And we found this middle picture, it's hard to get your bearings on what that is just because of the way the picture's taken. But there's actually water in, that's one of our micro pools. There's actually water in it. And you can see the red algae is growing up the side. It's very clear, so you can see the whole thing, but red algae is growing up the side. So down here in the bottom right-hand corner, you see this is Hematococcus as it's maturing and starting to turn red inside. It's still alive, it's just maturing and turns red. So we didn't expect to see that. It's something that surprised us as it grew and reproduced in our pools. So we learned a little bit about green algae and different types of green algae. We found other kinds. We're focusing in on the ones that were the most common and the ones that made a difference in how we treated, etc. There were other kinds that we found. But then we moved on to take a look at mustard algae. Now, typical mustard algae, the mustard algae that we're used to seeing, that's probably the most common, is something called eustigmatos. And you can see up here on the top picture on the right, that's eustigmatos underneath a microscope. Eustigmatos has a variety of classifications, right? But it has the same types of characteristics. Slow growing, tends to cling to the surface or the walls, brushes away but comes back, right? We found that it needs less light to grow, so it's very common in shaded pools or pools that may spend a lot of time covered. You're more likely to get mustard algae. It does resemble sand on the bottom of the pool, and I will caution all of you, I've helped many, many, many customers as they try to use an algicide to kill actual sand in the bottom of their pool. So know what you're dealing with and always check to make sure you don't have actual sand in the bottom of your pool. But yellow or mustard algae can be very difficult to get rid of. And that's for a couple of different reasons. One, if you see the bottom left-hand picture, it's got an A in the middle of it. That is eustigmatos that has been very highly magnified, right? This is beyond anything that we could do with the microscope. And I have to tell a funny story. And I know that Brian Trink, who is one of our lead research people, and his team has done the most work with this particular topic. I know he's listening and he's going to hate me for telling this story, but he was working with algae and he was so excited. He bought a new microscope and it was able to take pictures of algae and all this stuff. And he's a nerd, so he was nerding out over this really cool microscope that, he spent quite a bit of money on, more four figures at least on getting this microscope. So he's taking pictures and he's so excited, and they ran into an algae that they couldn't classify along the way. So they sent it off to an actual lab, an outside lab, to have it classified. And they came back with pictures like you see with the A in the middle of it here. And it was so far beyond what Brian's little microscope could do with pictures. And he says, I felt so insignificant. He was so excited about his microscope. And then the big lab's like, yeah, ours costs like millions of dollars. Let us do it. So it's just a funny story about, you think you have the best of the best equipment and someone's always got something better. So anyway, so you can see in the picture at the bottom, the eustigmatos. And what does that look like? And I ask this question when I'm doing live classes. What does that look like? And everybody always kind of says the same thing. It looks like an egg, right? And you're right, it looks like an egg, and it looks like it has an eggshell around it. And the concept of an eggshell is accurate for mustard algae. So mustard algae has a shell around the outside of it called beta carotene. So that's what that shell is made out of. Now, if anyone's familiar with beta carotene, they know beta carotene is an antioxidant. We find it in foods, it's good for your body, et cetera, et cetera. But it's an antioxidant. Chlorine, shocking your pool, what do you do to it? You oxidize, right? So chlorine is an oxidizer. Beta carotene is an antioxidant. What happens when an oxidizer and an antioxidant meet? They fizzle, they neutralize, right? So the chlorine, which we need in order to kill algae, we need it to be able to punch through the cell wall and do its work inside the actual algae cell. It can't get through that eggshell that surrounds mustard algae. So chlorine, using chlorine to treat chlorella works very easily, right? Using chlorine to try and treat mustard algae or eustigmatos isn't effective because it just gets neutralized as it runs into that beta carotene layer. A lot of times when you have mustard algae or eustigmatos, you'll find that you have a hard time holding a chlorine residual. You say, I don't know why, the water's clear, all I have is a little bit of mustard algae, but in reality, that chlorine is getting neutralized just through the process of running into that mustard algae cell, hitting that beta carotene layer and not being able to kill the algae, it just fizzles out. So, but we kind of knew that about mustard algae. We knew that chlorine wasn't the best. Copper is very, very effective against mustard algae. So we knew how to go about killing mustard algae. But then we started to dig a little deeper and we grew mustard algae. You can see a picture in the bottom right here. We also grew, get back to my screen so I can move on. This is you can see a good picture of our micro pool here now. So this is one of our 4x4 pools with the liner dropped in. And we grew what we were very confident was mustard algae in it. And so they pulled it out, they collected it, they put it under the microscope, expecting to see eustigmatos. And what we actually saw was something completely different. We saw something called Nietzsche, which is actually a diatom. We did not expect this, right? So a diatom is a completely different classification entirely. Now, this was in this picture that you see to the right. This was in something that we would have glanced at a pool and said, that's mustard algae. And we would have been 100% confident in our answer that that's what we were dealing with. In reality, if it's something like Nietzsche, it is a completely different organism. You can see in this video, it actually moves. That makes my skin crawl every time I see that. I always hate to see this video. But it actually has flagella, right? It actually has little algae feet. It moves around. These are single-celled organisms that have silica-based cell walls. So that's important because we have a lot of sources of silica in swimming pools. Now, diatoms in general, silica-based species in general, they estimate from 20,000 to 2 million different kinds of species. Diatoms, as a classification, produce 50% of the air we breathe. So they're important, but not in swimming pools, right? We don't want them reproducing in swimming pools. Some are planktonic, they swim around the waters, others cling to surfaces. There's a lot of different things that these organisms do in a pool, but they present themselves as mustard algae. That's what they look like, that's what they feel like, that's what they act like. When in reality, this looks a lot different than eustigmatos, right? But on the bottom of a pool, we're not able to tell the difference in what we're looking at. So when we found these diatoms, we did a little bit of research because that's what we were doing, right? We were on a journey of just discovery, trying to figure out what we didn't know about algae, right? So we did a little bit of research. We got some of the diatoms. You can actually buy algae and organisms online. Who knew? I call it Algae Mart. But actually, the University of Texas has one of the largest algae banks in the world that you can purchase algae from. And we did a little experiment with these diatoms, and the bottle to the left that you see is the sample that we have that has all of the nutrients it needs to grow and reproduce and all that sort of stuff. And then we pulled some of those diatoms out and we put them in two different bottles. One bottle had pool sand in it, which pool sand is silica, right? And then the other bottle had liquid defoamer in it, which is actually a liquid silica, if you don't know what defoamer is made out of. And we wanted to see, what would happen when we did that. And we found out if you feed them, they're going to grow. Now these diatoms didn't like the liquid silica. We didn't see any impact from that. But the sand, if you look in this picture to the right, you can see at the bottom of that container, you have a layer of sand down on the bottom, and then the fuzzy part that you see on top is actually the diatoms that are growing and reproducing, feeding off of that silica. So what does that mean in a pool environment? Well, it means two things. One, if you have sand in the bottom of your pool, you're more likely to have mustard algae or these diatoms growing in it, right? We still call it mustard algae, but these are diatoms. And if you have a mustard algae or a diatom problem, cleaning your sand filter as part of your process to get rid of it is absolutely an important piece of the process. And we forget that a lot of times. As pool care professionals, we do tend to cut corners sometimes, and cleaning the filter is something that we cut the corner on a lot. So anytime you're dealing with mustard algae, you're probably not going to know which one it is. You can't see it, the difference with your eyes. You need a microscope to tell, is it a diatom? Is it eustigmatos? What is it? But consider that it probably has diatoms in it, and it is feeding on the sand if you have a sand filter. So chemically cleaning that filter and making sure you complete the algae process or the algae kill process is an important part. So that was our classifications of quote unquote yellow or mustard algae that we found. Now, black algae, we didn't find a ton of new stuff about black algae. It's not really algae. It's not actually classified as an algae. It's really just a bacteria or a cyanobacteria that's photosynthetic. Black algae can tolerate a lot of extremes: extreme light, extreme dark, extreme hot, extreme cold. It's very easy for it to grow in a lot of different environments. Most species are what we call filamentous, which means they root down or dig down into the pool surface, which is what makes them difficult to get rid of because they're stuck to the surface. Everybody knows if you're treating a black algae problem, brushing is a huge part of the process, and you have to brush it every day in order to loosen it up and start moving through it and getting rid of it. Some black algae grow with these protective shells over the inside of the actual algae cell, so that if you don't break up that protective shell, all the treatment that you're doing is just bouncing off the shell and not doing anything to kill the algae. So we have to brush, break up the shells, loosen up the filamentous, the growth, and get the algae to where we can actually treat it. What we did find, the most important thing we found about black algae was we always think it grows in the rough spots of plaster, right? Or it grows in the places where, it's most worn down. Where black algae actually grows the most is in the areas of lowest circulation. So you see black algae on stairs all the time. Why is that? Because I've never seen a set of stairs yet that truly has good circulation in a swimming pool. Black algae starts to grow there. You see black algae starting in the corners of pools, especially old pools. And in the past, we would have said, hey, that's because it's old, the surface is rough, it's starting in the corner. In reality, yes, the rough surface helps it get started, but if you look at old pools, a lot of them are built as sharp rectangles, right? You see pools that are 30, 40 years old, they've got sharp 90-degree corners. If anybody knows anything about how water moves, water does not move in 90-degree angles. it will cut that corner off. It'll round it out, flow right around it, and not flow back into that sharp corner. Black algae likes to grow there because you're not circulating the water effectively. So it has a chance to settle, it has a chance to root. It's not getting moved around. And once it starts to root, that's when black algae grows and reproduces. This is why brushing your pool is important. And I get a lot of people, they say, I don't brush my pool every week. It doesn't need it. Your pool needs to be brushed once a week. Service professionals' pools have to be brushed once a week, whether they quote unquote need it or not, because they do need it. They always need it. Brushing a pool, brushing the stairs, brushing the corners is one of the best ways to keep black algae from being able to grow and reproduce. You're stirring it up. You're not giving it a chance to root and get started. Once it gets started, it just layers on and causes more and more problems. So brushing the pool is important. And I always tell people, I use analogies all the time when I teach. And I always tell people this, it's like brushing your teeth, right? If you get up in the morning and you forget to brush your teeth, we've all done it. It's okay. You don't really notice it in the beginning. But by the time you get to evening, what do your teeth feel like? They have fur on them, right? Or they have fuzz on them. Now you could smile at me, I could have a full conversation with you, and I would not see the fur and the fuzz on your teeth. Your teeth look fine to me. But if you run your tongue over them, you can feel it, right? You know that you need to brush your teeth, but I can't see that. Pools get fur on their teeth. They need to be brushed, whether you can see it or not. That buildup is happening on the surface, and they need to be brushed at least once a week. That's not to say brush your teeth once a week. You should be brushing your teeth multiple times a day, but you get the idea, right? So brushing is one of the best ways we can keep black algae from getting started. In reality, as we dug through all of these samples and we classified algae and we grew algae just so that we could kill algae, and we had algae everywhere. The reality is, when you pull a water sample out of a swimming pool that has algae, whether it's green or whether it's yellow or whether it's black, we rarely find one type of algae in that sample. Mostly we get a mixed population of algae, some syndesmos, some chlorella, maybe some eustigmatos in there. We get a little bit of cyanobacteria. You get a little bit of everything in that population, so that when you treat that algae, it's hard to tell, is chlorine the best option? Is a quat-based algicide going to work the best? Maybe it's copper, but what if I have that syndesmos stuff? Then copper doesn't work as well. What do I do in order to treat this algae? Because you standing on the side of a pool, or a homeowner bringing you a bottle of water that has green water in it, right? You can't tell if it's syndesmos or chlorella or eustigmatos or diatoms or whatever that is. All you know is there's algae in that pool. So when you're trying to select a good algicide, right, there's a lot that goes into that. You want it to be effective against all strains of algae. You want good algicides to be both algicidal and algistatic, which simply means it kills algae and it prevents algae. You really want it to work independently of the sanitizer system. So there are plenty of good options out there. For example, we have our Coral Seas products, our Yellow Out and our Green Aid. Those are great cleaning products that work with chlorine in order to kill algae. But they have to be used with chlorine. They're very, very effective. They do a great job, but they work with chlorine to kill algae and remove it from the pool. Most of the time, you want your algicide to work independently of your chlorine. Chlorine's got other work to do, right? We need chlorine to kill bacteria and sanitize and do all those things that chlorine does. So good algicide, you don't necessarily want to rely on it all the time to use your chlorine as part of the process. And then we want it to give no adverse effects, right? No foaming, no staining, no odor, nothing along those lines. So in our industry, we have kind of three categories of things that we would consider algicides. First and foremost, chlorine. Chlorine is a very good algicide. It will enter the algae cell, it goes in through the cell wall, right? And it oxidizes, that's what chlorine is, it's an oxidizer, right? It oxidizes all the cellular components that are inside that algae cell. it destroys the cell membrane and the cell dies. It's very simple, right? It goes in, it churns up all the insides, it destroys the cell membrane, the algae cell dies. That works in most cases. Now remember, with something like Eustigmatos, it can't get through that eggshell, that outer shell, in order to be able to do that. So it's not effective. In something like chlorella, chlorine's very effective at getting through that cell membrane and killing that cell. But one thing about chlorine, right? Killing algae should be maybe it's, I don't know, third thing that it looks like at in order of importance in a swimming pool, right? You put chlorine in the water first and foremost, you want it to kill bacteria. That's its number one job. And you always want to have chlorine available in the water to kill bacteria. That's how you keep swimmers safe. Its second job is to oxidize and remove contaminants, right? Because you need that oxidation process that chlorine gives in order to be able to break down the contaminants and things that you need to remove from the pool. Third job, maybe you want chlorine to kill algae, but you're using up chlorine at a rapid rate. And I know that all of us, whether we're at the pool testing the water or we're testing water samples that customers have brought in, but how many times do you see a water sample where you test the chlorine and it reads 0? We see it all the time, right? So when we see it all the time, we know we're asking chlorine to do too much. We're asking chlorine to do too much work, and there's not enough in there to get the job done. So we don't necessarily want to ask chlorine to do algae too. We're running out, we're using too much of it, and we're having trouble. So it's a good algicide, but we want to make sure that we don't use too much of it. So then we have our quaternary ammonia compounds. Our quaternary ammonia compounds they work a little bit differently. They're charged, they're positively charged compound, and they're attracted to the cell membrane of the algae cell, which is negatively charged. So it's like a big magnet. And those two things get pulled or attracted to each other. That plus end, that tail of the quaternary compound will tear open the actual cell wall of the algae cell. The cell wall or the cell membrane gets disrupted, and basically the guts of the algae cell start spilling out. So it's like stabbing someone in the gut, right? If somebody stabs you in the gut, your guts are going to spill out and you're going to die. It may take a minute, maybe a little bit slow, but it's very effective at killing. And that's what quat compounds do. Quats and polyquats, they poke a hole in the cell wall, the guts of the cell spill out, and the algae cell dies. Now, copper works even differently than that. So copper basically shuts down the internal processes of the algae cell. So it doesn't need for the guts to spill out. It just gets inside like a quick acting poison, and it disrupts the enzymatic activities, and eventually the membrane gets damaged, but it doesn't take much to do the job. It works very, very, very quickly, so that instead of stabbing someone in the gut and letting them die a slow death as their guts spill out, we have copper-based algicides that are more like a fast-acting poison. They go in, they get the job done, they work very quickly. And you guys can see a difference when you treat a pool with a quaternary ammonia or a quater polyquat. It works, but tends to be a little slower. Copper-based algicides tend to be a little faster. Now, in all of this research that we did, we found that sometimes compounds work better than copper. Sometimes copper works better than chlorine. Sometimes chlorine works better than all of them. Sometimes we don't know what type of algae we're treating, so we have no idea which algicide we want to pick. And that's where we get to the value of what we call a multifunction or a dual action algicide. And so we went into the lab and we said, okay, we need something different. We want a broad spectrum algicide that will kill algae, all algae, quickly. We want it to be non-staining, non-foaming, and we want to see if we have anything that we could blend into it to make it bigger, better, faster, better at what it does, more effective, etc. So our scientists went into the lab and said, we need a better solution. We need something more effective. We wanted something that no one else had. We wanted something that was easy enough for us to make so that we could manufacture it on a regular basis and meet the need from it. How do we make an algicide that works the best of the best, right? And we've gone to the table and we have basically taken all the good parts of copper algicides and all the good parts of our quat-based algicides, and we've blended them together with some other things that have some synergistic benefits to them. And we have created algicides that are multifunctional or dual action algicides. So we have some different options for that, right? In our Pro Series line, we have what we call our dual action algicide. In our BioGuard line, we have our Algae Complete, which is a little bit different, but the concepts are the same. You take the good parts of copper and what it does, and you take the good parts of quat-based algicides and what they do, and you put them all in the same place so that no matter what type of algae you're treating, because you don't always know, you are treating it the best way possible. If you have syndesmus in the water and you don't know it, and you just try a copper-based algicide, you're not going to be very effective. But if you try a multifunctional or dual action algicide, right, you're going to have copper and a quat-based algicide in there. All of a sudden, you're effective against syndesmus. If you have chlorella, gosh, everything kills chlorella, so you're going to kill it very, very quickly and get rid of it, right? If you have eustigmatos, you're not relying on chlorine because it can't do the job, but copper is very effective against eustigmatos. So you have the ability, you have copper blended into the product. So this dual action algicide is something that if you're a pool professional, if you're running a service route, this should be on every single service truck that's out there, because you do not need any other type of algicide to choose from. Prevention is great at prevention. You have an initial dose of 8 ounces per 10,000. And then after that, weekly, it's 1.5 ounces per 10,000 gallons. A small amount of algicide will go in and prevent green algae, whether it's chlorella or it's syndesmus or if it's hematococcus, it will prevent that from growing. It'll prevent eustigmatus and diatoms. It'll prevent black algae from getting started. It does all of the work regardless of what type of algae it is. Now, if you have a problem, same product, perfect for treating visible algae, right? So 16 ounces per 10,000 gallons is a treatment. Circulate for 24 hours, you brush, and then you will see results overnight when you're using this as far as getting killing the algae. The pool may go cloudy. We'll talk about that in just a second, just because when you kill algae, you then have dead algae in the water that you need to clean up. But this fast acting algicide that will treat, kill, prevent all types of algae that you find in pools. You don't have to classify it. You don't have to know what it is. This algicide will take care of all types of algae that's in the pool. Now, it works really well when you pair it with something along the lines of our pool first aid product. This is an enzyme clarifier combo that will go in and help clean up what gets left behind after you do the algae treatment, right? So it'll clean up the dead algae, it'll help with clarifier with that, it'll break down some of the contaminants that gets left behind. The enzymes break down non-living organics. So this, following it with this particular product, is the perfect way to get that pool back to clear as quickly as possible. Now, you can use some of these other clarifiers that we have. We have our Clear and Perfect. In the Pro Series line, we have our extra strength clarifier, our natural chemistry clear. But as far as true cleanup goes, the first aid product is probably the best product that you can use for that. So that is a new approach to algae that is extraordinarily effective. But we didn't stop our research there. We dug a little bit deeper and we wanted to look at nutrition and nutrients and other topics and how they affected algae growth. And again, we're looking at real world pool problems. What gets into pools? What causes problems? What are we doing? We're trying to learn about them. We're trying to figure out, again, the best way to kill algae. And these pictures just show some of the things we were working with. We have labs full of algae growing, sitting in windows. One little girl came through with her dad one day and she saw it in the window and she said, "Daddy, you didn't tell me you make potions." So we had a pretty good laugh about that. But we dug a little bit deeper into algae nutrition. And we were basing it on the concept called Liebig's Law of the Minimum. Now, I am a scientist and I don't think anything in science should be named Liebig, but that's just my opinion. But Liebig's Law of the Minimum says if one factor of growth is limited, then the overall plant growth will be limited. We said, okay, that's interesting. What does that mean for algae? So we dug in and we designed an experiment, etc. And we compared algae to human beings, right? So human beings need a balanced diet to be strong and healthy and ready to go, be full of energy, right? Ready to go do things. That includes fruits and vegetables, breads, rice, grains, things like that. Those are two major food groups. Meat, fish, proteins, milk and dairy is a food group. Cake is a food group. Anyone that tells you it's not has never met me because I can't survive without it, right? But we need this balanced diet with a little bit of all of these things, more of some versus the others, but to truly be healthy and strong and full of energy. So we apply the same concept to algae. And with algae, we found that the major food groups of algae has to have nitrogen to grow. It has to have phosphorus to grow. It has to have magnesium to grow. Some of the lesser food groups, it needs calcium, it needs iron, it needs carotenoids, it needs all these things. So we said, all right, if those are the main food groups for algae, what happens if we start limiting one of those food groups? So first thing we looked at, of course, was phosphate, right? Now, phosphate get in the pool from a lot of different sources, right? Groundwater runoff, drinking water, lawn treatment, some pool products put phosphate in. Phosphates come from a lot of different places. So keeping phosphates at zero is next to impossible. But it is something that we can test for. It's something that we can remove. It's something that we can limit the amount of in swimming pools. So we wanted to know, specifically for phosphates, what happens if we limit the amount of phosphate and try to grow algae. So we set up an experiment, not just with phosphate. We looked at several things. So all the way over on the left of your screen, I think it's the left, I don't think your screen is mirrored, is you see on the bottle chlorella, right? So we picked the most common type of green algae that we have, and we gave it all the nutrients it needed, all the air, all the light, all the water, all the food that it needed, balanced diet in order for it to grow. And then for all the rest of the experiments, we limited one thing. So in that first bottle, we limited the amount of nitrates. We took them out. In the second bottle, we took out the phosphate. So we're taking away food groups, right? In the third bottle, we took out the magnesium. And in the fourth bottle, we put excess calcium, right? So that's the most likely problem to have in a pool would be excess calcium. And we wanted to know, okay, what impact do those things have on algae growth? Everything else stayed the same light, the same air return, the same, all the other nutrients were the same. We just picked one thing for each and we limited it. So if you look at this left-hand one, remember this had everything it needed to grow. So this was a 20-day experiment. We went from this clear bottle to this in 20 days. This is very healthy algae, right? It's reproducing, it's full of life, it's very healthy. You can see under the microscope, there's a lot of algae cells or algae spores. You can see the parts around the algae spores that look fuzzy. That's actually the debris that gets left behind when these algae cells are reproducing. So we knew that this algae was happy, healthy, reproducing, and it was blooming. We looked at the bottle where we limited the amount of phosphate. Same 20 days, same nutrients. So I'll say that one more time. Same 20 days, same nutrients, except that we limited the amount of phosphate. This picture to the right over here shows how well algae grows when you limit the amount of phosphate. Now, it's still there. We didn't kill it, right? So let me be clear about that. Removing phosphate does not kill the algae, but the amount of growth compared to the amount of growth when you have the overabundance of phosphate is a huge difference. Which one of these would you rather try to control in a pool? This one, right? This is like the Superman of algae, or this one, This one's the nerdy kid that never goes to the gym and lifts weights, right? Which one's going to be easier to get rid of? This one, right? So when we remove phosphate from the water, we're actually, Liebig's law of the minimum, right? We're actually limiting how much algae can grow and reproduce. We're limiting its ability to bloom in a pool. It's still there. It's still alive. We still have to kill it. So we still need algicides. We still need to do all those things. But what's easier to keep under control? Which one are you less likely to have issues with or less likely to turn your pool green? This one, right? Because you have much less there that you have to try and control and get rid of. And that's simply by removing phosphate, right? We test for phosphate, we remove phosphate. We have several different ways to remove phosphate from pools, right? We have our phosphate product, which takes out phosphate over a kind of a slower period of time, easy to put in, doesn't cloud the water, takes out about 1,000 parts per billion each time you put it in, but easy to do, doesn't cloud your water over, and something that you can do to take out phosphates on a regular basis. In our Pro Series line, we have our Phos Remove products, a little bit stronger, will cloud the water when you put them in, but they'll take out more phosphates per dose. If you're purchasing any of these phosphate remover products from us, we do, just a quick reminder, we do offer a free phosphate test kit to anyone that asks. You go to our website, naturalchemistry.com, and request it, and we'll actually send one in the mail to you. So we'll give you the opportunity to test for phosphate. If you have a high level of phosphates in the water, we have our Phos-Free Max product. This is the strongest phosphate remover that we have. So this will take out high levels of phosphate. Now this is powerful. It will cloud the water when you put it in, but it will clear up, and it's very effective at removing high levels of phosphate. But the point is, we can limit the amount of phosphate in the water, which makes algae easier to kill, makes it easier to control in the pool environment. All right, I'm running out of time here, and I want to at least leave a couple minutes for questions. So let me just finish up real quick. I get asked a lot of times, what about nitrates? What if you limit the amount of nitrates in water? Same thing happens with nitrates. You can see the control over here, very green, very healthy. When we limit the amount of nitrates, we actually got the best effect by limiting the amount of nitrates. So I get, well, why don't we do that in swimming pools to help keep algae from growing? And I'll ask you this question. How do we remove nitrates? Water replacement, okay, we can drain and refill. Reverse osmosis, not on my pools, right? Strong base ion exchange resin bed, I don't even know what that means. Enzymes that aren't practical for swimming pool use. So really, yes, we could help the algae problem by limiting nitrates, but there's no realistic or feasible way to limit or remove nitrates from swimming pools. So if we could do it, we would, but there's just no way to do that. So we don't focus on it. We can control phosphates, we can limit phosphates. So by doing that, we get that effect of limiting the growth of algae. All right, final quick topic, and I just wanted to point this out because there's always, and let me just say, I'm not opening up the great cyanuric acid debate right here. That's not the point of this presentation or the point of what I'm doing, but I want to make one point about cyanuric acid and algae. And that is, there's some talk in the industry sometimes about how higher cyanuric acid concentrations means you're more likely to have algae. And the concept of that is basically it slows down your ability to kill algae. Therefore, the higher your cyanuric acid is, the slower you kill algae. The slower you kill algae, then the more algae blooms you're going to have. So I want to just show a couple of things very quickly. One, these are charts that were done in a big study out of Arizona State University. And this was done a while ago, 1980, but the data remains the same. And what this is showing is simply that as your stabilizer level gets higher, and this is at 1 part per million of chlorine, 1.5, 2 parts per million of chlorine, and these are different kinds of algae in all three of these charts. But they all show the same thing. When you go from 0 to 25, you get a little bit of a slowdown on how quickly we kill algae, right? Or how effective we are at killing algae. And then all the lines stabilize, and you find that you don't have any additional effects on them. So if you really wanted to say, yes, it slows or it inhibits our ability to kill algae between 0 and 25, I would say this. If you keep your cyanuric acid level at 0, how likely are you to have a chlorine residual in the water? Not likely. right? We need some cyanuric acid in there to be able to hold our chlorine level and make sure that we're killing bacteria. So the effect that you would get is a small amount as far as the effect on algae, and you get a bigger boost from being able to hold chlorine in the water. So this effect kind of goes away and then it just evens out anyway, and you don't see any additional problems. The really telling data is this: we were able to access real residential pool data, kind of an aggregate look at over 6 million water samples. And when we dissected down to samples that were marked that had green algae and compared them to their measured cyanuric acid levels, we would expect that as the cyanuric acid level went up, we would see more pools with algae, right? And what we found was not that. You can see in this chart here, at 0 CYA, 2% of the pools had green algae. At 150 parts, or 100 to 150 parts per million, 2.2% had green algae. At over 150, 1.8%. So we see there's absolutely no correlation between a rising cyanuric acid level and the amount of pools that we saw with algae. And that's real world 6 million pools worth of data that shows no correlation between the two. Okay, wow. Scott, I hope you're still on there because I expected you to at least interrupt a couple of times and I've just been talking. So where are we at? Do we have any questions or anything?
I've been riveted. There's so many things that that I've read about for a long time, and this has me thinking a whole different direction. And I mean, obviously, the CYA stuff, I've been reading about that forever, and that blows my mind. That data, 6 million samples.
Mm-hmm.
Well, I'm gonna have to actually sit and look at that for a while and try to get my mind around it. I wish we had more time for questions. We'll get to a couple, and I know that you can review the webinar after it's over, and I'm going to. So we'll get to that a little bit later. But one person asked, do different parts of the country have different types of algae?
We do find that for sure, that different samples from different places would have different types of algae in them. The ones that we focused on, like for this particular webinar, you will find pretty much across the board. But some of the smaller categories and some of the niche algae that we found, you do find different things across the country, yes. And we did include some of those in our algae kill studies and things like that.
Another person said, to prevent algae, is it better to use phosphate remover or add algicide?
The answer to that really is both.
Oh,
So again, phosphate remover doesn't kill algae. It will limit algae. It will slow down and limit the amount of food algae has, but algae is still able to grow and reproduce, just not as well and not as fast. So if you're using a phosphate remover, you're limiting the amount of algae that you need to control, and then the algicide has a much easier time of going in and controlling it. So the ideal situation, you would do a phosphate remover to get your phosphate level low, use a weekly product in order to keep your phosphate low, and a weekly preventative dose of algicide, which is not a lot. I mean, you saw on the products I was talking about 1.5 ounces per 10,000 gallons. That's not a lot of algicide that it takes in order to control that. So the both is really the best way to do it.
sure. Has Biolab ever done a multifunction algicide before?
We have not done
Okay.
multifunction in this manner. I don't think that we have, no. We have focused in on a copper algicide or a polyquat or a quat, but we've never done a blend before.
Well, then that leads to our final question, which is, where can I get it?
So we have some options. So our natural chemistry and pro series products are sold through distribution. You should be able to get them through any distributor. If not, simply ask and they can get them in. So if we have BioGuard dealers on the line, hello, always good to see you guys. You can buy direct, and we have some options for you that are a little bit different, but same concepts apply. So yeah, either way. But if you're not a BioGuard dealer and you want these products, we have our natural chemistry line has a full line of products, including phosphate removers, clarifiers, cleanup, etc. And you can buy them through distribution. Any distributor should have them.
Sweet. Well, that's all the time that we have. We're at the top of the next hour. This has given me a lot to think about. So I'm going to listen to this whole thing again.
Well, my email's on the screen. If anyone has any questions or wants some additional information, or you just want to have a dialogue about anything that I presented today, I am more than happy to engage and do that. So please reach out. Let me know what your questions are, and I'm happy to talk to you.
Well, thank you very much for being with us today, Alicia. That's been amazing stuff, and I guess we'll all get back to the job of pools.
Thanks, Scott. I appreciate it. Hope to hear from you guys.
Bye-bye.